The question 13 says, find points on the curve x square by 9 plus y square by 16 equals to 1 at which tangents are parallel to the x-axis, parallel to the y-axis. There are two parts of this question. And frankly speaking, if you can easily draw the graph of this equation, this represents an ellipse, right? Where the minor axis endpoints are on the x-axis and those are plus minus 3, 0, and major axis endpoints are 0, plus minus 4. What you'll get is this kind of a vertical ellipse. This is what I'll be getting, and please note this point is 3, this point is minus 3, this point is 4, this is minus 4. Okay, this is x-axis, this is y-axis. Once you are through with this, what we are doing is we are trying to solve the question orally over here, right? So find points on the curve this at which tangents are parallel to the x-axis. This will be pretty simple. Tangents are parallel to the x-axis at this point. This is 0, 4. And similarly 0, minus 4 will be another point at which tangent is parallel to the x-axis. What about tangents parallel to the y-axis? These will be the tangents parallel to the y-axis. This is the case of ellipse, and for ellipse tangents parallel to the x-axis and y-axis are very, very simple, right? But then this is using graphical approach. What can we do for this question where we have to solve it analytically, let's see. So in that case, let's try to solve finding the derivative first of all for this equation. We have x square by 9 plus y square by 16 is equal to 1. Can you differentiate this? Yes, differentiate. 2x over 9, differentiating with respect to x. The derivative of x square is 2x. The derivative of y square is 2y times, since we are differentiating with respect to x, this is what you get. Derivative of 1 is simply 0. On basis of this, I can get the value of dy by dx. This gives me dy by dx is equal to what? Minus 2x by 9 upon 2y by 16. 2y by 16. And this tells me dy by dx will be equal to what? Please note that dy by this 2 will get cancelled with this 2. This is minus 16x over 9y. This is what I'll get. Okay. On basis of this, can you solve the first and second part as given over here? We are supposed to find tangents which are parallel to the x-axis. Let's solve the first part over here. For tangents parallel to the x-axis, the slope of tangent will be 0. dy by dx equals 0 implies what? This implies that minus 16x over 9y will be 0, which gives me x will be 0. Okay. Once you get the value of x as 0, tangents parallel to x-axis, x equals to 0, implies what will be the value of y from the original equation of the ellipse, right? From the original equation of the curve, let's find y. Therefore, 0 plus y square by 16 is equal to 1. This gives me y square equal to 16, or y equals plus or minus 4. And therefore, the points, these are the required points. Can you observe? 0, 4, 0, minus 4 are the required points at which tangents are parallel to the x-axis, right? 0, 4, 0, minus 4, these will be 2 points. Let's solve part 2 then. Part 2 says tangents parallel to the y-axis. Now, if tangent is parallel to the y-axis, the normal, which is perpendicular to the tangent, will be parallel to what? The normal will be parallel to the x-axis. Tangent parallel to y-axis implies normal parallel to x-axis. Okay, that's pretty simple. If normal is parallel to the x-axis, therefore the slope of normal will be 0. Implies minus 1 upon that derivative, minus 1 upon this dy by dx, which is minus 16x upon 9y is equal to 0. This gives me simply 9y upon 16x is equal to 0, which further tells me that y equals 0. Okay, if you get y equals 0, can you also find the value of x with the help of the equation of curve? Yes. Therefore, x square by 9 plus 0 is equal to 1 over here, right? This is equal to 1. Okay, and this tells me x equals plus or minus 3. The 2 points at which tangent is parallel to the y-axis, tangent is parallel to the y-axis will be 3, 0, minus 3, 0. These will be the 2 points at which tangents are parallel to the y-axis. That's what we have over here, and that's all in this question, as you can see.